Alright, the answer to this rational expression multiplication division question is either one of these. The negative quantity x plus 4 over x, or if you want to distribute it, the negative x minus 4 over x. Either is acceptable. This is more likely to be a part 1 solution as opposed to this. This is the original problem. You can see that it is multiplication and division. And I just factor and transfer, factor and transfer. And notice that the division symbol does become multiplication, and the fraction that follows it gets flipped, reciprocated. So this is just simple AM trinomial, difference of two squares here. This is AM trinomial. This is greatest common factor, and that's the one you always want to look for first. Always see if they have something in common. We factored out an x here. Now, this is where we flipped it, so the numerator gets factored on the denominator, and the denominator gets factored on the numerator, etc., both of which are AM trinomial. This really wasn't a real difficult one. You just have to remember that anything divided by its complete self is 1. I mean, if you have x plus 2 over 3 plus x, that is 1 as well. But if you have something over its complete opposite, as in the case of the x minus 8 and the 8 minus x, that's going to simplify to negative 1. So you can see the x minus 8 over the 8 minus x, I cross them out and replace that with a negative 1 on top. I always circle it right away so I don't forget about it. So I have a pair of x plus 7s, simplify to 1. A pair of x plus 2s, simplify to 1. A pair of x minus 1s, simplify to 1. And a pair of x minus 2s, simplify to 1. Thing left on top is the x plus 4, and on the denominator, the x. So you multiply the tops across what's left, and I get this. Multiply the bottom across what's left, and I get the x. Check this by mock substitution. If it's a part 1, you could actually do it with mock substitution. The answer to number 2 is x plus 3 over 2, and it is indeed another division question. You can see that we changed the division to multiplication like we did before, and the fraction that followed, we flip it. And there's just a bunch of factoring going on here. This is what I like to call factor completely, because it required 2 stages of factoring. First, I took out a 3, and I was left with x squared minus 9, which I further factored with the dots, difference of 2 squares. This was just straight up greatest common factor, factoring out a 6. You can see the denominator here went to the numerator. The numerator went to the denominator because the fraction that follows gets reciprocated, flipped. Simple AM trinomial, factors of 12 that add to negative 7. And here is that tricky trinomial nonsense because it doesn't have a greatest common factor. So we're going to have to do grouping. In order to do grouping, we need 4 terms. We only have 3 here. So you multiply the 3 times the negative 20 and you get your negative 60. We need factors of negative 60 that add up to negative 7. That happens to be your 5 and your negative 12. You can put it in any order. It doesn't really matter. It's all going to work out in the end. So now I'm breaking up the negative 7x as negative 12x plus 5x. You see, it didn't change. Now we have 2 pairs. So I'm going to group these 2 together, factor out a 3x. I'm left with x minus 4. I'm going to group these 2 together, factor out a positive 5, and I'm left with x minus 4 as well. These 2 binomials have to be the same or we're done. We can't factor it. And they are, so we're going to factor out the x minus 4. And I'm left when dividing that out with the 3x plus 5. So if we go back to the problem here, now we do our simplification. Anything divided by 1 is itself, anything divided by itself is 1, and anything divided by its opposite is negative 1, which wasn't apparent here. So you have your 3 over 6, which became the 1 over 2. X plus 3, nothing can simplify. A pair of x minus 3s, a pair of x minus 4s, and a pair of 3x plus 5s. Circle that stuff so you don't forget it. Multiply top across, bottom across, and we're left with the answer here. Once again, this could be checked with mock substitution, something like an x is a 3 or something like that. As a part 1, it could have been done with mock substitution. Alright, this is number 3 on the rational expressions, multiplying fractions, rational expressions of fractions. The answer is a squared plus b squared over a. This was the original problem. You see it's a little bit more complicated here because you do have the situation where there are double variables, so you have your a's and your b's. This is difference between two squares. If you look over here, it's like a factor completely question. First thing that I do is I do the difference between two squares by taking the square root of the front, square root of the back, expressing them as conjugates. This I couldn't do anything else with because this is a plus sign there. I said there is no such thing as sots, there's only dots. But I did go further on to do this with another difference of two squares. Take the square root of the front, square root of the back, express them as conjugates. So this whole thing is now factored completely. We bring this back into the problem. This is a trinomial. It's one of those rare things, to get into the little tricks on how to do it. Just know that if you have an a squared and a b squared, and minus 2ab would be a minus b, a minus b. If that were a plus, they would be plus signs. It's just a perfect square trinomial. Here you can't do anything with it. It's just a binomial already factored. And this is greatest common factor, so I factor out the a. Remember, anything divided by itself is 1. Anything divided by its complete opposite is -1. Can't do anything with the a squared plus b squared. But we have a pair of a plus b's, a minus b's, a minus b's. And I'm left with the a in the bottom, and the a squared plus b squared on the top. So multiply the tops across, bottoms across, and we get this fraction here simplified. If this were part 1, you could have done this with mock substitution, substituting a is 3, b is 5, etc. Looking for an equivalence relationship in the choices. As a part 2, you could check it with mock substitution.